When you think of a jet or turbojet engine, you probably think of it as an advanced piece of modern technology that's difficult to break down and understand. In reality, it's actually neither. The jet engine has been in use since the 1930s and still powers most aircraft in the world today. The entire apparatus works using just a few basic principles of physics and three thermodynamic components. The entire engine functions through the interactions of a compressor, a combustor, and a turbine. The basic concept that a jet engine uses to move a plane forward is the same concept that helps us walk or makes a ball bounce off the pavement, Newton's third law of motion. For every action, there is an equal and opposite reaction. In this case, the action is the jet of air shooting out of the back of the engine. The reaction to this is called the thrust, and it's the force that pushes the plane forward. So the goal of the jet engine is to maximize the thrust of the airplane by maximizing its own jet propulsion. This is achieved in multiple ways within the engine. The first of the components in the engine is the combustion chamber. By burning an atomized jet fuel, the chamber has the ability to very rapidly heat the incoming air. Raising the temperature of the air will increase its energy and increase the magnitude of the jet propulsion. However, the basic laws of thermodynamics state that to combust the air effectively, the air coming into the combustion chamber must be at a relatively high temperature and pressure already. This is where the compressors come in. These rotating blades spin and add energy to the incoming air. This additional energy raises its temperature and pressure for more effective and more fuel-efficient combustion. One of the significant advantages of the jet engine's design is that to some degree it powers itself. This final engine component is the turbine. As high-pressure air exits the combustion chamber, it spins the turbine. The turbine and the compressor blades are connected on the same shaft, which runs right through the combustion chamber. So, the energy that the turbines gain by spinning goes back to powering the compressors. This is essentially like placing a fan in front of a wind turbine and then having the turbine power the fan. All that is needed is a steady flow of wind, and the system will power itself. Now, you may have noticed that the turbine powers the compressor blades, but the turbine can only work if the compressor blades are already spinning and generating airflow. So how does this process get started? The turbine is started with an external electric spark plug prior to flight, in the same way that a spark plug is used when you first start your car. Finally, note how the engine casing is narrower at the end. This creates an additional pressure and forces the air out at a higher speed. So, with these three components, we have achieved the purpose of the engine. The cool, low-pressure air enters, and hot, high-speed air is pushed out the back, giving us our thrust. The thrust pushes the airplane forward, and it's the job of the wings of the plane to generate the lift. There are a few ways that the jet engine design has improved in larger engines. A second set of compressors, powered by a second turbine, can be added. These components would have their own shaft that runs concentric with the original. Adding more compressors increases the temperature and pressure of the air entering the combustion chamber. This improves fuel economy and thrust. These engines are called two-spool engines because of their two shafts. More commonly, engines with more than one shaft are referred to as turbojet engines. Another improvement that is often made is adding a large fan at the front of the engine. This fan pushes some of the cool air around and straight past the compressors where it becomes pure thrust. This allows the compressors to add even more pressure and temperature to the smaller amount of air that they receive. These fans are the giant blades that you see when you look at an engine from the front. An engine with this fan is appropriately named a turbofan engine, and almost all commercial aircrafts use turbofan engines today. So, that is how a jet engine uses basic mechanics to generate thrust. A compressor, a combustion chamber, and a turbine work in unison to generate propulsion.